In this video, we're going to talk about building a confidence interval for an unknown population mean when the population standard deviation sigma is known. So for these cases, our parameter of interest, the thing we're estimating, is our population mean mu. And that means that the corresponding point estimator, the middle of our confidence interval, is going to be the sample mean x bar. Our critical value is going to be pulled from the standard normal curve because I know that when I am looking at instances where sigma is known, sample size is large enough, or the population is normally distributed, the central limit theorem tells me that the distribution of x bars should be normal. So I'm allowed to use the standard normal curve to calculate my probabilities for my confidence level. I also know for a sampling distribution of sample means that the standard error, sigma x bar, is equal to the population standard deviation divided by the square root of the sample size. So the standard error portion looks like this. And I remember, and I'm going to do this in a little smaller color up here, that my confidence interval should be my point estimator plus or minus a critical value times a standard error. So in this case, my point estimator is x bar plus or minus my critical value times my standard error. And the question is, where does that critical value come from? So we're going to go over that in the next two examples. Make a mental note that this is coming from our confidence level. So let's go ahead and do that first example. So it says, suppose average pizza delivery times are normally distributed with an unknown population mean and a population standard deviation of 6 minutes. A random sample of 28 pizza delivery restaurants is taken and has a sample mean delivery time of 36 minutes. Find a 90% confidence interval estimate for the population mean delivery time. So first thing that I see is that last sentence very clearly tells me what I'm building and what my parameter of interest is. It says 90% confidence interval, so I know I'm building a confidence interval, and it says for population mean delivery time. That's my parameter of interest. So I'm going to do the state step first. I know that the population parameter I'm estimating is the population mean pizza delivery time. I'm going to pick out all of the other numbers that are given to me in the problem. So as I go through the problem, it says population standard deviation of 6 minutes. So I know that sigma is 6. If I keep going, random sample of 28 pizza delivery restaurants, that sounds like a sample size. So n is 28. And then the next has a sample mean delivery time of 36 minutes. Sample mean is x bar. So x bar is 36. And then it says find a 90% confidence interval. So that's my confidence level. Confidence level is 90%. So the next thing I'm going to do is figure out what my critical value is, because I know I need that in my do step. So to do that, I'm going to come up here in a different color, And I know that I'm looking at a standard normal distribution. So I'm going to draw a quick standard normal distribution. And I know standard normal is 0, and then 1, 2, 3 standard deviations out on either side. And what I want is that 90% confidence, I want that in the middle of my curve. And we know a little bit about the normal distribution. I know 68% is within 1 standard deviation, and 95% is within 2. So I know that I'm somewhere between 1 and 2 standard deviations on either side. So that is 90%. And I want those scores, negative z and positive z, that form that boundary. And there's a couple ways to do it, but the easiest is with the TI-84 and the inverse norm command. As I know inverse norm is going to ask me for an area, it's going to ask me for a mean, it's going to ask me for a standard deviation, and then a tail. So we're going to feed it an area of 90% in decimal form, 0.9. A mean of x bar is 0 and 1, because we're looking at the standard normal z. And then our tail is in the center of the curve. So let's go ahead and run that on our calculator. Second bars, inverse norm, 0.9, 0, 1, and then center. And we get negative 1.645 and positive 1.645. And for our critical value, we only need the absolute value. So we just need that positive edge, 1.645. The reason I don't need both is the plus or minus is right here in the CI formula. So I don't need to pull them both from the calculator because that plus and minus issue is tackled right here. It's built in. So the next thing I'm going to do is my plan stage, and I know that's just stating what I'm doing, and I am doing a z interval for a mean. So it's a confidence interval based on the standard normal, or z, for an unknown mean. And then the do, I'm going to use that formula we have up here. I'm also going to show you what it looks like on the calculator if you prefer that method, but I'd like you to see both. So our formula is x bar plus or minus our critical value times standard error, sigma over square root of n. So we're going to go ahead and plug those values in. Our x bar is 36 minutes plus or minus, and then our critical value is 1.645, and our standard error is 6 minutes over the square root of our sample size of 28. And that's going to give us two numbers, one for the minus and one for the plus, and we usually write them in parentheses with a comma in between. I do the minus first, so 36 minus 1.645 times, and then we've got 6 divided by the square root of 28. So I have, for this lower edge, 34.135. I'm going to go out 3 places for funsies. And then I want to do the same formula but with a plus in the middle. So I'm going to go up and copy that and then just go change that to a plus. And I get 37.865. And if you look at those two values, you'll notice that 36 sits exactly halfway between those two. And that should always be true. Our sample statistic, x bar, should always be the center of that interval. That's a good clue we did it correctly. On your calculator, we just did a z interval. It turns out if you go stat tests, there is option 7, z interval. So on your calculator, if you want to do this, you're going to do z, I guess I should write this. You're going to do stat, you're going to go tests, and then you're going to go option 7, which is z interval. So let's go ahead and do that and check it gives us what we had. You'll notice it gives you two options. Data is for when you were given a raw list of sample data. You would put it in a list and choose this. It asks you where you put your data. We had summary statistics, sample mean, and a population standard deviation, so stat. And it asks for sigma, x bar, n, and confidence level. And you should always enter your confidence level as a decimal. And then we go down to calculate, and you'll notice it spits out exactly what we got by hand. So it doesn't matter which method you use, you should end up in the same spot. The question then is our conclusion. What does our sentence frame look like? So for confidence levels, we are always going to start out with we are blank percent confident. I know how to spell. That the interval from blank to blank captures the true, and then you're going to put your parameter of interest in context here. So for us, I'm going to go back in green and fill it in. So we are 90% confident that the interval from 34.135 to 37.865 captures the true mean pizza delivery time. The upside to being really careful when we do the state, plan, and do step is the conclude step goes quick. I should have my confidence level labeled clearly. I should have my answer in the do stage labeled clearly. And that context from the problem, the parameter of interest in context, should be what I defined as the parameter of interest up here. I am literally just copying that down here. So anytime you're doing a confidence interval, for any type of confidence interval, this is our sentence frame. We are blank percent confident that the interval from blank to blank captures the true parameter of interest in context of the problem. We're going to do one more a little bit faster, and then I will set you loose for some practice. So next example says, a random sample of 50 cars in the drive-thru of a popular fast food restaurant revealed an average bill of $18.21 per car. The population standard deviation is 592. Estimate the mean bill for all cars from the drive-thru with 98% confidence. So I'm estimating the mean bill. So mu equals the population mean bill for all cars from the drive-thru. And then I'm going to label everything I was given. So random sample of 50 cars, N is 50. Revealed an average bill. So that was a sample average, X bar, of 1821. And a population standard deviation of 592. And we want to build a confidence level of 98. Because I have sigma and I'm estimating mu, this is a z interval for a mean. So for our estimate, I know that it's going to be X bar plus or minus my critical value times my standard error, sigma over square root of n. So 18.21 plus or minus, and then I need to figure out what my critical value is. So we know we draw that standard normal curve. Zero in the middle, 3 standard deviations out in either direction. I use the empirical rule. I want 98 in the middle. I know 2 standard deviations is 95. 3 standard deviations is 99.7. So I'm between 2 and 3 standard deviations. So negative z is here. Positive z is here. I know this area in the middle is 98%. And I'm going to run my inverse norm command. Second R's, option 3, this time 0.98. Everything else stays the same. And we get 2.33. And then our standard error sigma is 5.92 over square root, and our sample size is 50. So 1821 minus 2.33 times 5.92 divided by square root of 50. And then to get the upper bound, I take that expression and I do addition instead of subtraction. So I've got from 16.259 to 20.161. And then my very last step, my conclusion, I'm going to use that sentence frame. So we are 98% confident that the interval from 16.259 to 20.161 captures the true mean bill for all cars from the drive-thru. I'm going to go back in here. I know that this was money, so I should attach some units here. So the answer to the question, we are 98% confident. Interval from 16.259 to 20.161 captures the true mean bill for all cars from the drive-thru. And I don't know why I put a closed parentheses there. All right. If you have any questions on how we do confidence intervals for means where sigma is known, feel free to send me emails or drop by office hours. Otherwise, I will see you in our next video.